So our final speaker came all the way from Germany, Patrick Renner. He's the head of R&D and CEO of Pomfort GmbH, a software company specializing in media management software for digital images. He gained experience in a broad range of post-production workflows during his work at a large post facility, likely in Germany, right? During his freelance work for companies in the area of film and video, he's involved in software projects, color management, video transcoding, packaging, digital film cameras, media management. He worked as a research assistant at the Chair for Applied Software Engineering at the Technical University of Munich. Do you like beer? He drinks beer. I wanted to put something in here that wasn't obvious. And he holds a university degree in computer science. All right, Patrick, help us to appreciate the Media Hash List.
Hello, hello, hello. Hello, everybody. So thanks that you made it through the talks so far until this late presentation. My name is Patrick Renner from Pomfort, as Al introduced me already. Our company does software for media management on the film set, which means that, and contrary to what we heard already about this huge media asset management systems where you have centralized storage and put everything in there, talking about ingest, etc., when we're talking about data management on the film set, this is a very decentralized way of data management. You do a lot of copying and transportation of mobile storage. So this might be a little bit different, and we came up with requirements and needs there specifically for these kinds of distributed workflows. So imagine a scenario where you are on a film set and you have a digital a film camera. Maybe one word on the digital cinematography issue. So when you think about the transition from film to digital acquisition on the film set, there of course there's a new flexibility, there are new possibilities for workflows because you get your hands much earlier on the material that you acquire. But also an important part is missing, and that is the digital lab, the analog lab, the film lab. And that film lab had the responsibility of labeling stuff and putting film rolls into the shelf and providing media and all the information to later post-production steps. And this is missing. So this responsibility moves to the film set now. And there I want to show you this file-based aspects in contrary to the film roll aspects. So you say we have this media cards there coming from the camera. You probably don't have enough that you pile up your entire production in that media cards. They're quite expensive, so you're copying and offloading this information to some RAID devices there on the film set. And then you transport them, and in your post-production facility or digital lab or editorial or whatever it is in your workflow, you have to copy again to put that on your online storage there. So what happened is you have two copies being made, and the important thing is that you end up with the same data on this online storage here than you had on the camera media, of course. And if you imagine yourself copying documents or whatever from your USB stick to your computer, you probably find yourself regularly checking if the folder size of the source is the same as on the destination, and you have this strange feeling that that's probably not enough to be 100% sure that the data is copied properly, but still it gives you a clue that if the size is right, then you have copied that properly. But this feeling that it's not enough includes something like statistics and trust, and this is the thing exactly what where this media hash list that we propose comes into hand, because it solves that problem of this uncertainty if that data is copied properly over those generations of copies. So I want to go shortly through a list of possible errors that can happen during that copy processes. The one part of the errors is technical errors, so copy could be aborted by some technical problems with cabling. As I said, we are talking about film set where you have a lot of improvisation about cabling and devices. Maybe it didn't work at all because the the disk system wasn't attached properly. You have incomplete transfers. I already saw zero-filled files that are just black or appear green, depending on the codec, that contain wrong metadata, that contain whatever happens there. I don't know. Some reason might be that physical bit errors occur, so that your media that transports physically your data is kind of old or how to say, it received their cycles of read and write cycles. So this all can happen. And then, of course, you have the human factor, and this is, you probably, or maybe you aborted the copy and only forget to restart that. Or it might not be happen too often, but still it's possible that it's manipulation, so that someone might want to change that content that was created on the film set. So how do we usually maintain that data integrity during that copies? So one thing is organizational. As long as you have access to the source media, of course, this is quite simple. You can always compare the source media to the copied versions. But as I said, we are in a distributed scenario, so you don't have that source media available very soon. So you need some kind of end-to-end control of that copies. And that could be that you maintain lists of what should be on that copies, or that you do visual QC that tells you if the material is okay, but doesn't tell you if something's missing, for example. So these are various strategies that help, and again, the feeling stays that you're not sure if it's exactly what happened in the camera. And technological, there are of course, there are solutions out there. For example, in the DCI specification, there are lists of files, there's a packaging list, and so there is a specification on a very high level of abstraction, or abstractions. And there are, of course, tools on a very low level of abstraction, like copy tools that do checksumming and verification during copy. And what we are trying to do is heading in the middle a little bit. So not going in the abstraction layer too much and talking too much about the concrete application, but not talking about tools and bits too much. So the idea is to have a digital delivery receipt. So that is a list that travels with your media files along the chain to post-production. And this includes, of course, a list of files. This is simple. It's just a list of files. And it includes something that allows you to verify if the files are the same as they were in the camera later on. And I will talk about that in a minute. And then the third thing is the trust thing. As long as you don't know when that list was created and when this information for verification is created, you can't say if it is now the same material that has been recorded in the camera or the same material that has been put into a van and brought to the post-production facility. Something could have happened before that. So we created an XML format for that, for this kind of list. And we did that with two of the biggest post-production facilities in Germany. And we're very happy that they talk together because they don't like to talk to each other too often. But in that case, they found that it's important to have something to exchange and to trust what comes from the film set. And so with our knowledge from the data management perspective and from the technical perspective, we built that XML format. You can look up the details of the XML format in the paper. So I don't want to go into that in detail. So now about the verification part. Imagine you have an image, and this image is represented by some data. And the hash value algorithms that are existing take that data and produce a fixed number of that from that data. And the special thing is that no matter how small a change in that data is, for example, you have some flip bytes here that reproduce a green spot here in the image, that only might be a pixel. The hash value that's created by the hashing algorithm is completely different. And the special characteristics of this hashing algorithms is that the probability that two images that are not the same or two different images reproduce the same hash value goes to 0, this probability. So what you get is if you have different hash values, the image has to be different. And this hash value is usually just a few bytes, so it's 128 bits or something. So this is a very small number that can travel along the files. And now what you can do is you create the first hash value when you do the first copy after you get the media from the camera. So you have this first hash value of the media. Then you copy the hash value and the media. And then you copy that copy of the hash value and the media, and so on and so on. You can do generations of copies. And at the end, when you want to make sure that that material is the same that you had in the beginning, you just do another hash value and compare if that value is the same that you did in the camera. So this allows you to be exactly sure that the file is the same as you had in source file without having a need for direct comparison of the source and the destination. And this helps us a lot. So let's see. Sorry. So now I want to show you a little bit how that works now, bringing that everything together. So imagine you have a folder of files that you want to transport here. It's a few QuickTime movies here, and you have a camera report, it's a PDF file. So this means that it's not important what file format that is or what's in that file, because the hashing algorithm happens on data. So, and this last file that you can see, the MHL file, this is the file where the list is with the hash values. And now, one thing is still missing, and I'm not sure, I lost, yeah. And this is, so to sum up, we had the completeness is done by the list of files. So we have a list of files with these hash values that allow us to be sure that the content of the files is correct. And now what's missing still is the trust thing. So if you're not sure when this list has been created, you are not sure if it's really the same material that has been created at the very beginning. So we are using digital signatures for that to sign that list of hash values. And this also is done by or something similar is done in the DCI specification. So what actually happens is that the creator of that XML file, that list, has a private key somewhere on his device. And with this private key, he signs, there's also hashing included, he signs that document. There comes a signage there, it's a few bytes, a handful. And every receiver of that signed list who has the public part of that key can review that really the content and the signage fits together, and that this comes from this one creator that had that private key. So what you can make sure is that what you can do is you can sign indirectly the entire content, because you signed the hash values, and these hash values make sure that the content is right, and with the signature and this digital signing, you make sure that this hash list is okay. So and this all together gives you a list that really assures that what you had at the beginning is what you had at the end. So that's, so far that's the main part is set so far. So about the qualities of that media hash list and the workflow that comes with it. And I want to show you one thing more that is now a little bit more about the workflow. So imagine that you collect information or you collect media data over your shooting day, for example, and do several copies of cards to one hard drive. And then in the evening, you're copying that again somewhere else. So what your aggregating copy process is kind of, and the naive way would be in that copy B to create a new media hash list. Again, a list with hashes, and sign that. But what you lose is kind of the verification of the very, very, very early copies here. So what we thought would be helpful is if that media hash list has mechanisms of referencing other existing media hash lists, because there is the trust of that early copy already and the hashes from there, and you don't have to recreate all the hashes again. So you just create a list referencing other hash lists, sign that, and you're done. And the work that has to be done then later on, if you verify that, is you verify that media hash list, the pink one, and have to recursively run through all the other hash lists that are referenced, and finally you have the same. You have an indirect signing of your content over several hierarchies. So I want to give you just a short idea how the project context is right now. We have implemented a predecessor of that format, so it's not XML yet, but the predecessor is implemented in these two post-production facilities. So they're doing their big movie productions, the transport from media from set to post-production with such a format. And we implemented that in our data management software, which is creating such lists on the film set because we're taking care of the copying and the management of the files. So that's used right now, and we're right now in the transition of implementing that XML because the signature is still missing. That's what we're doing right now. And what the next steps is for us, I think metadata is still an issue that we have to address. In XML, you can, of course, extend everything and put more information in, but we should define a way of embedding metadata into that file, because you might want to add organizational metadata, so who did a copy, what tools were involved, what team was involved. You could add metadata, technical metadata, like describing more about the file, so what ASA was the camera set to, what time codes are embedded there. So that could be part of that list already. And of course, user-created information, such as ratings. Was this a circle take? So that kind of QC information that might be available already on the set. So this might be things that could go further into that DTD, so the specification of how that XML file could look like. And we think that this kind of hash list could be incorporated in various ways of workflows. So not only in that digital cinematography, but also in more broadcast environments as well. As long as you transport media from one place to another, I think that could be applicable. And just to give you one thing to think about, I think the best thing would be if cameras would create such hash lists, of course, because then you're sure that the camera, really the creator of that media, already brings along something to verify against if you transport that media along. That's it so far from my side. So it was a little bit quicker than I thought, but thank you very much.
Patrick, that was very interesting. And any questions for Patrick? Oh, please, just use the microphone then. Arjun?
So I had a question about how you manage the keys, because you said you'd use private keys to sign the hash and then use the public key to verify. You have to distribute those keys to those ends, right?
Yeah, that's always the problem when you start talking about private key and public key infrastructure, is the infrastructure part. And I think in these kind of workflows, it's not necessarily needed that you have that infrastructure of maintaining that keys. So you could start, so the keys can, or the public keys can go with this hash list. And so the first time you get the hash list, you see, well, there, I can call the guy that made that file. And so, is that yours? Okay. And from then on, I just have to take care if this key changes. So I don't think it's necessary in that kind of scenarios that you need an infrastructure where you have databases full of keys, etc. but it might be useful in other scenarios. So we didn't address that, but I think there are solutions out there that cover that.
It appears from your workflow that you're basing things on doing a single copy from the original media to something like a RAID drive and then distributing from there. And all of the DIT work I've been involved with, we always make multiple copies from the original media, not from the first copy, but from the original media, at least 2, sometimes 4. I'm wondering how you would handle that sort of a situation.
Did you hear the question? So often in his workflow, there's multiple copies made to assure that nothing ever gets lost or corrupted.
Yeah, from the original media.
Yes.
So
that's what I usually say in talks when I talk about media management on film sets, to make at least 2 copies, because that's not, you can't say that too often. So I completely agree that 2 copies or more is the important stuff. Not having 2 copies here on my slide was just simplifying that, but assuming that that's important. I don't think that this makes things more complicated, because you can use these mechanisms and these kind of lists, of course, for multiple copies as well. So for example, our software creates multiple copies at once. So it's made for that kind of scenario, to create multiple copies on multiple drives, 2 or 3 or how many you like, and have these lists there as well.
I've got one question for you, especially tied in with the hash itself, not the list so much, but the hash itself. And the talk previously by Shibata-san, that there's a strong relationship there between a unique identifier to identify a piece of material, which a hash is in fact a unique identifier as well.
But not vice versa.
Well, in what sense? If I change 1 bit in a piece of content, I would think the UMID would have to change. If you change 1 bit, the hash changes. They're locked. They're synced. It would seem to me, I'm simplifying it here, but in most cases, so a lot of the problems that he's trying to solve, you're trying to solve, and it seems like that there's an overlap here in some conceptual ways with regard to having something that's unique. They're both unique. They both identify the same piece, hence they're both linked. What do you have to say about that?
Yeah, that's right.
So is there any way we can leverage the 2? Link the 2?
Probably that's part of that, what I said about metadata, embedding, because I think hashes and UIDs have different aspects that they shouldn't be.
They're not identical. I realize they're not mirror images of one another.
Yes, and for example, with these references, or what was it called in the UMID? I'm not familiar too much. So that part of the UMID stays the same, and you just change parts of it.
True.
That completely breaks this idea of the hashing value. But a part of the UMID, of course, could be created, and that was a question for the last talk, could be something like a hash.
You two should have coffee together. I think you can come up with something.
Is there coffee now?
Tomorrow. So that's it. So thank you very much for joining us again. 6 o'clock is a general meeting. Also 6 o'clock, this party starts in the next room. So hopefully you can do both. Thank you.